Okay, so we are going to be working on 4.5, Part 2, Integration by Substitution. So at the top of the notes here, we have a list of all the things that you want to make sure you do when you try a u substitution. So first thing you want to do is pick your u. Then you're going to find du. So those are our first two steps, u and then du. You're then going to rewrite your integral in terms of u. Then you're going to take the integral, and then you're going to plug back in for u, and you can always check your answer by taking the derivative by working backwards. So remember, some tricks that you might want to pick for your u is you might want to pick something in parentheses, an exponent. If your exponent has something in it, under a radical, and a denominator. So those are good starting points for your inside parts. Okay, so in the box here we have, these are just the formulas and theorems for the u substitution, but sometimes they can be a little challenging to try to navigate your way through what it means. So again, what we're going to be doing is finding the inside part. So what they basically said here is the integral of u to the n, you still do your power rule, you add 1 and you divide, but then you plug back in for u when you're done. Okay, so let's keep going with a couple practice problems. Let's start with number 1 here. So number 1, I'm going to start with this inside part right here is my u. u equals 3x minus 1. Okay, so next I'm going to find du. du is 3 dx. And this happens to work out perfect because I have a 3 dx in the problem. So if it helps you to color code, that might be a good idea, or doing circling and underline, whatever helps you figure out how to substitute. So we're going to do the integral. U is the part that I've underlined, and we have a 4 left, so u to the 4th, and then everything else that I circled is du. So the next step, we're going to take the integral. The integral of u to the 4th is 1/5 u to the 5th plus c. And then the last step, we're going to plug back in for u. Okay, so let's go to number 2. Number 2 has 2 parentheses. So we got to figure out which one is going to be the most helpful. So if I pick 2x plus 1 as my u, the derivative is 2. That doesn't equal anything else in the problem. If I pick x squared plus x as my u, that derivative is 2x plus 1, and it actually ends up being this other part over here. So I'm going to pick this as my u. du would be 2x plus 1. Okay, so it works out perfect again. So I have my u here, and then everything else is my du. Nothing left over. So that's the integral of u du. So next thing I'm going to do is add and divide. So that's 1/2 u squared plus c. And then we're going to plug back in for u. So 1/2 x squared plus x squared plus c. Okay, let's go to number 3. So I'm going to rewrite this. I have a radical. Anytime you have a radical, you want to rewrite it. Okay, so I'm going to pick the inside part here. u x to the 3rd minus 2. du would be 3x squared dx. So it works out perfect. It matches perfectly with the other part. So I'm going to circle. This is my du. this is my u, and I'm left with a 1/2. So what that would be, it would be the integral of u to the 1/2 du. So now I'm going to take the integral of this. I'm going to add and divide. So 1/2 plus 1 is 3/2. So 2/3 u to the 3/2 plus c. And then we plug back in for u. So u is x to the 3rd minus 2 to the 3/2 plus c. Okay, number 4. So looking at number 4, I've got a denominator and I've got a set of parentheses. So I'm going to start with the very most inside part, and I'm going to pick that as my u. 1 minus 2x squared. So I'm going to find du. Du would be negative 4x dx. So again, that works out really nice for us because that is equal to the other part. I still have this square on the bottom. So I'm going to write this as the integral of du over u squared. Now we're not used to seeing the integrals written like this, so I'm actually going to write it how we're normally used to seeing it. I'm going to write this as 1 over u squared du. It's the same thing, but I always write the du on the outside because then I don't get it confused with the actual problem. Okay, next thing I'm going to do is I'm going to rewrite this as the integral of u to the negative 2nd. So that all I have to do is my power rule where I'm just going to add and divide. So if I add 1 to this, I get negative 1. Divide by that, I get negative u to the negative 1st plus c. And then the last step, we're going to plug back in for u. Okay, so let's move on to number 5. Okay, number 5. Now I want to pick one that's going to equal the other. Now which one do you think is an inside part? So right away I see this squared. Now if I remember about trig functions, we can also write this as cosine squared in parentheses. So right away that shows me that I'm going to want to pick cosine because that's an inside part. So I'm going to pick cosine as my u. Du, the derivative of cosine is negative sine. So in this one, I do have to add something in. I don't have a negative sign. I have a sign. So I'm going to put in a negative because I need it, but I'm going to balance that out with another negative on the outside. So really, I didn't change the problem. A negative times a negative is a positive, but I fixed it so that I have a negative sine x dx in the problem. So I've got cosine is my u, so I've got u squared. Negative sine x dx is du. And I've got that negative on the outside that I'm going to bring down. So I'm going to take the integral. Integral of u squared is 1/3 u cubed plus c. And then we're going to just plug back in for u. Negative 1/3, u is cosine of x cubed plus c. Okay, number 6. Again, I see a radical, so I'm going to rewrite this. Now, this one is a challenging problem, so I want you to, if you need help, you can email me, let me know. We can always go over this again. Or just rewatch this a couple times. Keep working through it. That's the best way to get this problem practiced, is just to keep redoing it. So right away I see an inside part. So let me underline this. We've got u is equal to 2x minus 1. So du would be 2 dx. And here's where we have an issue. This part's okay, right? I'm going to rewrite this right down here. U to the 1/2. The problem is I have an x dx in the problem. not a 2 dx. So right away I've got one issue that I don't have a 2, so I will add the 2 in, because I do need that. So I'm going to add the 2 in, and I'm going to balance that out with a 1/2 on the outside. So I'm going to bring that down 1/2. Now the only other issue is I've got this x left over. So I've got the 2 dx. I've fixed that problem, so I'm going to put du down here. But I've got this extra x left over. So I'm going to show you how to fix that. So right now though, why don't we just write down what we have so far. I had to add in a 2, so I balanced it out with the 1/2. I brought that down. 2x minus 1 is our u to the 1/2. And then the 2 dx is our du. And then we've got the extra x, so I brought that down. Okay, so how we're going to fix this? So I can't take the integral yet because I've got an x and a u in the problem. So what I'm going to do is I'm going to do some side work here. And I'm going to use this formula right here to help me out. The u equals 2x minus 1. What I'm going to do is I'm going to solve that for x. So if I solve that formula for x, I could add the 1 over and divide by the 2. So x would equal u plus 1 over 2. And I can plug that in for my x down here, and that'll fix the problem. I won't have any x's anymore, I'll have all u's. So I'm going to rewrite this. 1/2, the integral. X I can write as u plus 1 over 2 times u to the 1/2 du. Okay, I'm going to clean this up a little bit so I can take the integral. So I'm going to pull this 2 out. It's a constant, so I can do that. So that would give me 1/4 on the outside. And next I'm going to distribute my u to the 1/2. So remember from Algebra 1, when we distribute, we add exponents. So u to the 1/2 times u, that would be u to the 3/2. And then u to the 1/2 times 1 is u to the 1/2. And we're finally ready to take that integral. So I'm going to add and divide. I'm going to bring down this 1/4. But adding and dividing, adding 1 to 3/2 gives me 5/2. So 2/5 u to the 5/2. Plus adding 1 to 1/2 gives me 3/2. So 2/3 u to the 3/2 plus c. Now if you want, you can distribute the 1/4. I'm just going to leave it. And I'm going to do my very last step. I'm going to plug back in for u. And from the top, u is equal to 2x minus 1. And we are finally done with that problem. So again, that's the hardest type of problem that you could see. So make sure if you need extra help, just rewatch that a couple times. Keep redoing it. You'll get better at it. These are tough. Most of the time, U substitutions are pretty easy and straightforward, but sometimes you get ones where it doesn't work out perfect and you have to manipulate it and work with it a little bit. Okay, so let's do our last problem here. So I'm going to start by rewriting this because I see this funky trig function here. I'm going to write it as sine of 3x to the second power cosine of 3x dx. Okay, so let's pick what we want to start with here. Okay, so I can pick the sine, I can pick the cosine. If you pick the wrong one, you can always start over. So I'm going to pick the one that looks like it's on the inside. I'm going to pick the one in parentheses, right? That's one of our tricks from the top there of our notes. Pick a parentheses to start out with. So I'm going to pick sine of 3x as my u. Okay, now we have to remember how to take the derivative of something like this. When we take the derivative of a trig function and there's an inside part, that's a chain rule. So I'm going to take the derivative of the inside, which is 3, times the derivative of the outside. The derivative of sine is cosine dx. Okay, fortunately, most of this matches perfectly. I already have the cosine of 3x dx right here. I'm just missing the 3, so I'm going to put in a 3, but I'm going to balance it out with a 1/3. So the only thing left over is this little 2. That's the only part I don't have underlined. So I'm going to bring down the 1/3 that I put on the outside. I've got u, which is the red part I underlined, u squared, and then everything else is du. Okay, next part, let's take the integral. So I'm going to bring down this 1/3. The integral of u squared is 1/3 u cubed plus c. And if you want, you can distribute this 1/3 through. You don't have to. You don't have to distribute it to the c because any number times a constant is still a constant. So this would be 1/9. I'm going to plug back in for u, which is sine of 3x cubed plus c. Now, some of you may have noticed that there's certain patterns that you can see. Some of you might be really good at these, and you might be able to do a lot of this in your head, which is perfectly fine. Some people can envision the answer right away and just write the answer down. That's fine if you're one of those people. If you're not, you have all the steps that you can write out each time. It's the same process every time, which makes it really nice because I know some of you guys like doing steps in your math problems. This is perfect for that because it's the same steps every time. So again, if there's one that was tricky to you, go ahead and rewatch it as many times as you want.